Okay, right. Hello everybody. My name is Dennis. I'm from Motorhome-World, and today we would like to do a brief demo of an automated BVM. So this is a BVM, and what most paramedics do is to give patients a bit of forced air. They squeeze it at a certain rate and let go of a certain rate. So it's what's called an inspiration and an expiration. I'm very new to these terms, so please excuse if I'm ignorant with the terms. What we are trying to do here as Motorhome-World is to repurpose some of our machines, our expertise, to create and hopefully lessen the load on medics to be with the patient by automating this particular BVM. So I want to be very clear that we are not trying to create an ICU ventilator by any stretch. We're just trying and see if this concept does work. We've done a proof of concept, but I need to know from other people and experts if this is something that could be used in the coming days or weeks. And we try to keep it very, very simple. I'll show you just now, but the idea of this is that it only works with air pressure. So we've got our air pressure plugged in from a compressor. It's our factory air, so it's not clean air or anything like that. The air is used just to drive the system. It doesn't go to the patient. Anything to the patient goes through the BVM. So again, just to reiterate, it's very basic, it's very simple, there's lots of adjustments. So please feel free to comment on Facebook, write a comment. I've got my iPad here, which means that I can try and answer some of your questions as they come through, once I've figured out how to see most of the comments. This is also a first for us. So I'm trying to figure it out as we go along. I'm in no rush. I've got people here, so we're going to show you a couple of things, and hopefully it will help. Right, I'm going to run through the machine quickly. So as I said here, this is the supply line to push the piston, which I will take the top off just now, you can see. We have a very basic on and off valve to switch the machine on and off. We've got a pressure meter with a adjustment valve on top that will determine the amount of pressure in the whole system. Then we have an inspiration rate adjuster and an expiration rate adjuster, so that your inspiration-expiration ratio can be set to your knees. And then we have an adjuster here for volume, the amount of volume that the patient can give. We have prepared little sample lungs to prove concept. So it's little plastic bags that we've used some of our fiberglass infusion equipment here. And this is, for example, a 400 milliliter bag. So we made these little bags, we measured them out. So this takes exactly 400 milliliters. So what we're going to do, the machine is going to blow these up to see exactly for the volume, that you've got the right volume. And it shows you that we have control over volume in this machine. We also have little bags here of 240 milliliters and 320 milliliters. So those three bags we have here. And hopefully that will prove that we've got control over volume. So we'll get to that now. Then the other thing we have is the breath rate. So it's a rate. So we can adjust. I think the lowest we got the machine to go is 9 breaths a minute. But from there we can go up very easily and very controllably as well. Right, so take the lid off, put that one side because I don't need that one anymore. So the BVM itself, any BVM can be used. It's very adjustable in size. So only thing happens that goes in there and then it sits in. then your valve goes on the end, and that takes care of that. Obviously, the BVM oxygen side is over here as well. So you can, we also have the little bag here. I don't know where it's lying in here, the reservoir bag. You obviously can put on here as well. So that's just lying in the box down here. Right, so it's very simple. You can see it is all air. We're working with a small air cylinder that uses a little bit of air. That will push this plunger out, and it works like you can search us now. We have some adjustment here as well. So there's a bit of spring loading here. So that we can also adjust. So if there's too much pressure on the back, then that will also give way a bit. Then the cylinder also is pressure sensitive. So you can set the pressure. If there's too much restriction, the stroke will come back automatically and then start again. We'll show you that as well. So to start off with, I'm just going to switch it on. The machine will start, and very easily you can see that's the stroke. It's working. So let's just do the volume first. Johan, I don't know if you want to show in here quickly. I don't know if you can see it clearly. So in here we have a little scale and a little pointer. So this entire cylinder can move backwards and forwards, which then means it determines how much the cylinder actually pushes the BVM in or out. So we can adjust that by volume. So at the moment we're anywhere between 240 and 400 mils. So as I turn that one to less, you'll see here, Jan, if you want to show in here, that you can see now we're moving it to 240 mils. So we've calibrated it, so once in that line, the amount of air being pushed out by the BVM is 240 mils. So I can show that to you by taking our lung, our chest lung, and I'm just going to squeeze it now. We're going to put it in water, so the water will collapse the lung and expand the lung and collapse the lung again, the water pressure. So it just makes it easy. So I'm just going to collapse it, put it in the water, and then you'll see, so it's not fully inflated, the 400 millimeters. This is the 400 ml bag. So, and now if we start adjusting that to our 400 ml mark, also the camera, we don't want to block the camera that recording for later as well. So now we're going up to 400 ml. And now, Jan, if you want to come look here again, you'll see now that we are inflating the bag a lot more. I can show you like this as well, so it's a little bit better. So we can up the volume a bit. There, let it just go to that. Obviously, the blow valve will still work. See, now we're getting there. See, now we got to 400 ml. So you can see the bag, entire bag is inflated. I'll ask Brian to change this to a 320 bag, so we can show that we can control the volume. Yeah, you can do it now? Yeah. Oh, you got 240? Yeah. Okay, we can do the 240. We'll just move it down to 240. All right, Brian, if you want to do that quickly. Okay, while Brian changes the bag to a 240 bag, I just want to explain some of these. Okay, you're ready. No, just leave it there. I'll connect it now. So let's just quickly do the inspiration-expiration ratio. So Johan, if you can move the tripod so that it stands over here, so they can see the actual piston. So there's two settings here. It's the inspiration, so that's obviously, you can see the speed it's doing now. I can slow that all the way down by adjusting this little valve here. So it's going a lot slower. See how slow it's going now. So it shows you, but we can also obviously speed that up. And you can see the fine adjustment we can do on the inspiration-expiration ratio. See how much faster that's going now. That's the inspiration, and obviously it's the same with the expiration. So you see how fast it's going back now. So now we can slow that all the way down again till 0. So then you can get your ratios you wanted to, or whatever the medics want as a ratio, is very finely adjusted by these two. Yeah, I just want to see if there's any comments at the moment. It doesn't look like there's any comments. If somebody can just write me a comment to say testing, then I know it's working. Let me just set this reasonably back to a 1:2 ratio. That's a reasonable 1:2 ratio. We just need to slow both a little bit down. So, thanks, Andre. I saw your comment. Right, yes, so I also want to show you the breaths, the breath rate. So the breath rate here, we've got a little delay, a timer, a pressure timer. Now unfortunately a lot of these parts, or a lot of parts that people use are going to be in very short supply. And one of those is the pressure timer. The pressure timer allows us to pause the cylinder at the when the expiration is done. We can pause the cylinder before it starts inspiration again. So that those timers are going to be in very short supply. So we've actually made our own, which consists at the moment, we can make this all from stainless steel obviously, of just a little 24mm polycop tube. And then we have a little valve here, which we then can adjust the pause. You see now there's, if I do a little bit more, see if I can get to about a 3-second delay. See, you can see the delay starting. 2001, 2002, 2003. You can see the delay. So 2001, 2002, 2003, 2004. So that's about a 4-second delay that we have, which will equate, like I said, we got it down to 9 breaths a minute. That's how we got it. I'm sure with if we go ahead and we make the proper machine stainless steel, we can get it probably down another to 8 with our own timer. If by any chance we get proper timers, then obviously then we can set this delay to 30 seconds, which gives you 2 breaths a minute. But for now, we also trying to understand that there will be shortage of supplies and parts. So I need to take that into account. So,
Brian.
So Brian, can you just check if that is still recording?
Yeah.
You see, okay, thank you. Right, let's just do the volume quickly of the, which one did you put on, Brian?
I've done both 320 and 240.
Okay, so let's just turn this one all the way down. And then we can do a 240 milliliters. Why am I saying milliliters? Used to milliliters. Okay, I'm going to screw that on. Okay, so here we have 240. Okay, so that's not even 240 yet, as you can see. So we can screw that up. So the markings and the scale inside here, we obviously will refine as we go along. We can able to machine it much finer. So. Here we go, now we're getting there. See, now we're getting there. We're almost at 240. Yeah, I think we have a leaking lung. One of these bags is leaking. So, let me try the 220. You want to see if you can get another 240 on there, Brian? Yeah, so that's obviously a lot lower. There we go. So if we watch that. So we're getting to the volumes. Yeah. Oh, there it is. Wow, now we got something. Yeah, just put the pressure up a little bit. There, that looks right, doesn't it? That looks quite nice. Yes. Perfect. You can actually hear the overpressure valve kicking in there. There we go. That's a perfect about 320. I'm just going to take it down a little bit. But I think we're about there. All right, but you guys get the idea of the control of the volume itself. Yeah. Let's see if there's any comments. So, what about test by medical producers and approval? Will set. So yes, obviously, I'm sure everybody in the world is in the same boat. To put new machines and ventilators that people put in, to get it through the normal process is going to be impossible. And again, I want to reiterate, we are not trying to create an ICU ventilator. We're trying to create something as basic as we can get, no electronics at the moment, zero electronics. Obviously from here we can start adding things on to introduce electronics to make it even more accurate. But I want something that works and might be sufficient enough to allow a patient to get some air and free up a nurse, free up a hand that's supposed to squeeze this bag to go and do something else. So more machines, more. So I'm trying to create numbers, if that makes sense. Yeah. Because now, what happens to timing when the lung less compliant? Is it hold closed by hand? Are we talking, I don't know if you're talking now about peak leakers. So obviously you saw the timing. Obviously my hand on the lung was just to collapse it. It was just to show volume, that we control the amount of volume going in. I don't have another way at the moment to show how much, to show you the control over the volume we have between 240, 340 and 400 or anything in between. So this was my way of showing when I just squeeze it by hand so that you can see we're filling the bag with a certain amount of air. That's what I was doing it. So there's going to be a lot of questions from the medical experts, I suppose, about this. But yeah, I hope that this works. Rikus, yes, the obvious design would be to work without electronics in the open loop control.
And mobile.
Sorry, I'm just lost. And then use electronics to provide better control. Yes, add-ons. Even add-ons, like, for example, at the moment we're working off our factory air system, which we have, but nothing stops us from having a little, oh sorry Brian, you want to get toolbox? A little extra box, toolbox next to it, with so then you can have your 12 volt air compressor to supply you the air. So, and the only thing you need is battery. So if there are triage tents or there's tents and field hospitals out there that don't have all the resources they need, the only thing you would need is the little air compressor and this machine and a battery for power supply. And you could, again, free up hands for somebody that needs it more. Andrew's asking, can this be used on one more patient at a time? I'm sure it does if we if we tee the air off and you put enough force in it, so we got stroke force. So if we put enough force in it to create an amount of air that can be divided between two patients. Something we need to test. It's something I haven't worked on yet, but we can, if we carry on with this, we can work on that. Rick, I understand, but what happens when you squeeze? Okay, so Rikus is asking, understand, but what happens when you keep it squeezed? Okay, yes, I can show you that quickly. So if I put the pipe back in, obviously I just put it in here. So Johan, if you just want to focus on here quickly. So if I now close, you'll see how far we've set this one up. Let's just give it a bit more volume for a bit more effect. Then you'll see the effect is a bit better. So you'll see how far it's actually squeezing it now. So so what happens, you see to all this where the stroke actually is going now. Just want to get it a bit more force so you can actually see for effect. So there you can see it came to about here. So if I now close my pipe off and I stop the supply, then I just need to do this. Then the stroke doesn't go as far. So another way of probably showing you a bit better now, because I remove this and I put my hand on it. So that's how far the stroke goes at the moment. You can see if I now stop it almost halfway this, see, so it retracts. It doesn't want to push all the way through. It doesn't need to go. It will stop halfway. If I let it go now, it goes all the way again. So there is some pressure sensitive on our pusher and on the cylinder itself. I hope that makes sense and that it's good. Does the timing change if the lung cannot be inflated? No. So timing is all set by this. So you saw just now that there is a bit of sensitivity on push, so it will not over-inflate, it will not over-push. But the actual timing is completely manual. So this is a pressure assist ventilator, not a volume control ventilator. No, it's okay. I'm scared to call it a ventilator. Personally, I call this an automated BVM. But the only thing I'm doing, I'm automating this. That's basically what I'm doing, with obviously a lot more control. But it's for me internally, it's an automated BVM. Call it a ventilator if you wish, but yes, this is what I call it. Obviously, the patient side we haven't spoken to about. I don't know if you want to put it back here. We haven't spoken about the actual patient side yet. But there will be obviously your scavenging pipes and your mask top feet. So that goes back in there. So everything after this to the patient will be the pipe to supply the air, and then obviously the diverter. So there will be a diverter on here, which will then scavenge. I don't know how to pronounce it actually perfectly. Scavenge the air out of the window, underneath the tent, get away with it, filter it. Obviously then you can have a PEEP valve on that as well, which will then allow a little bit of pressure on that side, as I've been told. But again, those are details that I am sure that medical experts will know. Our primary focus here at the moment was getting air to the patient, and there are systems and consumables available to do scavenging of the actual exhaust or the expiration from the patient. Okay, so what else have I got? Because of pressure assisted. Yeah, we spoke about masks. Yes, Bill. Yes, we actually we do have a small line here of where we use our upholstery department. They actually now making face masks. I don't know how much we're doing at the moment. It's not very big. Like what do we do? 800 a day, I think we are doing. But that's a separate issue where we actually created masks. For you guys, okay, because again, yes, it's a BVM, but if you use a design like Amity open source, it delivers constant volume. It doesn't matter. Don't matter the pressure. Yours provide a certain pressure, but not necessarily the same volume every time. Yes, not exactly the same volume if there's too much pressure, if there's too much back pressure on the system. But again, you can set that. So this is the stroke force. If you want to ensure a certain volume, you up the stroke force, and this piston will push it. It will push it. I don't know how that goes in between, how that will work out. The medics will tell you that. But if you up the stroke force and you've set it to 400 milliliters, it will supply 400 milliliters if the stroke force is strong enough. What did I want to say? Oh yes, so we've procured some of these toolboxes. I don't know if you can see that, yes. So the idea was, if we carry on with this, to mount this entire system in a simple off-the-shelf toolbox. Easy to carry, you can have consumables in it. We try to choose one with a little nooks and crannies, as I was told before by somebody, to sanitize it. But it's an easy toolbox. The BVM will actually fit in here as well, so you will have holes where we will stick the BVM and the valves out, and then everything actually what you see here will fit in the toolbox. And then you can have another toolbox, maybe another color, which will then house an air compressor and a little air tank. That was the idea of this all. Right. Okay, Rikus, got you. Thank you. I'm glad I answered your questions there. All right. Yes. So, let me switch it off for now. Yes. Again, it needs refinement. We know here how to make it better than what this is. Obviously, there needs to be a demand. If this process as we made here is by the expert and they go, you know what, there's no chance that any of this will procure any of these things, then obviously we're not going to carry on. So we hopefully with this video, and we're recording a video as well at the moment, which we will edit and then put on YouTube later. So obviously the doctors at the moment are extremely busy. The experts and the anesthetists are very busy at the moment. Hopefully they will watch this video and give us feedback, and then we need to make a decision what we're going to do going forward. We're very keen, we're very excited about this. We want to take it on and refine it. We know we can do better, of course. But yes, we started this on Friday. When was the first video up? Friday. It was Friday. So today is? Tuesday. And this is what we've got. I can have this mounted in that box by Thursday, Friday. Give it to somebody. Take it, go test it. Yeah. Obviously, people, the sooner we act, the better. Supplies is going to get short. Cylinders, valves, all of these things that you see here will be in short supply. The sooner we act, the quicker we can get on the supplies and get the stuff here. If we leave it too late, we will not get what we need for the amount that we need. Right, let's see if there's any more questions. Okay, minimum pressure. It actually works of 0.05 bar. It works off very low pressure. Disadvantage with that low pressure is the moment you get a little bit of back pressure from the patient or from the BVM, it's going to go back. So there is a balance. So ideally, ideally it probably will run off half a, if I set my pressure to half a bar, which is about that. It's using it now. I just need to know obviously this. So if I now put a little bit of pressure on here, it goes back immediately. So you need about 1 bar of pressure. You need about 1 pressure to create and to handle a little bit of the back pressure. Bill of material. Yes, I do, but not yet. So after this concept, we're waiting on the experts to give us feedback, to see what they would like to see additional on this, to see what they want us to change. Maybe they say that the expiration ratio is not good enough or accurate enough, or the volume is not accurate enough, and we need to do some changes here. And then I don't have a problem making a bill of material available to people. All right. Any more questions for people? Anything I forgot from the people watching behind the cameras? So it was a team effort. Don't forget, people. This is a team effort for us. This is not just me. It's us. There's a lot of people in the background that are working on this to try and get that where we are right now. So very proud of what we've done so far. I think in the amount of time that we've been able to do this is impressive. I'm impressed with all the staff here at Motorhome-World.
I think the big advantage there is also that it's mobile.
Yes, mobile. Yes, toolbox, mobile. That's what I said.
Yeah, no.
With, yeah, you can take it field hospitals. You can take it to lots of places. If you have air available, bonus. If you don't, take an air compressor, a little air compressor with a little air tank. You don't need a big tank.
Especially field
And a battery. And you could operate this. You can put a comment on the YouTube. You can send us a message on Facebook. Contact us by email. Questions. We're more than willing. We have a WhatsApp group going that's helping us with a lot of experts. Lisa is our contact person. She's handling all of those things with all the experts trying to get together. So yes, send us a message. See where you can help as well. Or maybe if you like it and we need to help you, it's also possible. Thank you for watching. I'm going to cut it off here now, and then we'll see messaging if necessary. Thank you.